Welcome back and welcome to the beginning of fourth quarter. We're going to start a new unit, which is we're going to talk about polynomials over the next couple of weeks. A polynomial is an expression whose only operations are addition, subtraction, and multiplication. Variables can have an exponent because an exponent is just a shorthand way of writing multiplication. X squared is just x times x. So addition, subtraction, and multiplication, but it could include exponents. So if we look at these examples, on the left, these are all polynomials. 5 times x cubed minus 3 times x. X plus 3 minus 2 times y. All we have is addition, subtraction, and multiplication here. A number, 5, is a polynomial. It's a very simple polynomial. X, just a single variable, is a polynomial. 7x divided by 11, that is a polynomial. That's a polynomial because this is the same thing as the number 7/11 times x. This is multiplication. Remember that when you multiply a fraction times a whole number or a variable, it multiplies into the numerator. So you can have division by a number, but you cannot have division by a variable. These, on the right-hand side, are not polynomials. This is the absolute value of x minus 3. The absolute value bars make it not a polynomial. Here we have square root of x. A square root is not a polynomial. And at the bottom, we have 5 divided by 3x. Because the x is in the denominator, this is not a polynomial because there is division by x. We're going to have a lot of vocabulary about polynomials over the next couple of days. The first word is term. The terms of a polynomial are the values in an expression that are separated by addition or subtraction. So with a polynomial, it's important to know how many terms are in each polynomial. They are the values that are separated by addition or subtraction. This is 3x plus 5y minus 6. I have 1, 2, 3 things that are subtracted or that are separated by addition and subtraction. So this has 3 terms. Here I have 18, that's one term, plus x minus y plus 4x. I have 1, 2, 3, 4 terms. 2x to the fourth plus 7. I have 1, 2 things that are separated by the addition. This has 2 terms. Here I have 1, 2, 3, 4 terms. So we just look at how many things are separated by the addition and subtraction symbols. When we write polynomials, we like to write them in descending order. Descending order means the powers or the exponents of a variable decrease from left to right. Descending means going down. So here, if we want to write each polynomial in descending order and then also state how many terms it has, we have to go and find the term with the highest exponent and write that first. So my highest exponent is 5. Then I go looking, is there any term with an x to the fourth? No. Now I have a 5x cubed. My next term is going to be this x squared term. Important point here. When you look at each term, the sign that is right before it goes with it. So up here, because it was first, this was written as negative 3x squared. When I change the order, I have to write minus 3x squared. That's my x squared. Now I go looking for x to the first, which is just the x term, plus 9x. And then the term with no x's, minus 8. 5, 3, 2, 1, none. I'm in descending order. I also want to state how many terms there are. 1, 2, 3, 4, 5 terms. In the second example, I go and find the term with the highest exponent. And again, this sign that's right before it goes with that term. So if I'm going to write this 8x to the 8th first, it's going to be negative 8x to the 8th. Then I go looking for the next exponent, next lowest exponent, 3x to the 7th. That's added, so it's still plus 3x to the 7th. Then I have this minus 4x to the 5th. Here's a 9x cubed. It's at the beginning. It's positive, so it's plus 9x cubed. And then I have the plus 5x squared. It may be helpful if you're doing this on a worksheet to underline things or cross them out as you go to make sure that you don't miss any. I need to count the terms. 1, 2, 3, 4, 5. This again has 5 terms. The next terms all refer to the things that are within the polynomial. Each term of a polynomial is either made up of a coefficient and variable, or it is a constant. We've talked about coefficients before. A coefficient is a number that multiplies a variable. We talk specifically about the leading coefficient. The leading coefficient is the coefficient of the variable with the highest exponent. The reason that that is called leading is that when we write the polynomial in descending order, the leading coefficient is the coefficient of the first term. A constant is a number without a variable. So all the numbers are coefficients except the one that's not multiplying a variable. Here I have x to the 4th plus 5x squared minus 3x plus 7. There are 1, 2, 3, 4 terms. The coefficients are all the numbers multiplying the variables. Now this x to the 4th doesn't have a number written in front of it, but we need to remember that whenever you don't have a number in front of a variable, I have 1 of the x to the 4th. So it would include 1 in my list of coefficients. The x squared has a coefficient of 5. And this x, again, the negative, the minus that's before it goes with that term. So I'm going to say the coefficient is negative 3. The leading coefficient, I have to go find the term with the highest exponent, and this one was written in descending order, so it's the first one. And the leading coefficient is the coefficient of that term. The constant is the number that doesn't have a variable, the 7 at the end. When we talk about polynomials, we identify them by their degree. The degree of the polynomial is the highest exponent. Couple little notes with this. If it's just an x, that's a degree of 1 because x means x to the first power. If there's no variable, that's degree 0. If you remember from earlier in the year when we talked about exponents, anything to the 0 power is 1. So you won't see the x if it's degree 0. So for these examples, we want to give the degree of each polynomial. I look at all the terms, find the one with the highest exponent. This is second degree. Or you could write degree 2. Here, again, this one is also in descending order. The highest term is here. This is degree 5. Be careful because they're not always written in descending order, so it's not always the first exponent. We have to go find the term with the highest exponent. This is degree 6. And in the last example, 2x plus 5, there's no exponent written here, but again, x is the same as x to the first, so this is degree 1. One last example where we're going to put all of these things together. We're going to identify the number of terms, list the coefficients, the degree, the leading coefficient, and the constant of the polynomial. As long as we know what all these directions mean, there is no calculations involved in the work. We just need to know what we're being asked for. Number of terms. That's all of the values that are separated by addition and subtraction. I have 2x to the 4th, 5x to the 7th, negative 9x, and 3. I have 4 terms. The coefficients are the numbers multiplying all the variables. 2, 5, and over here, again, be careful, the coefficient is negative 9. To find the leading coefficient and the degree, I want to look and find the term that has the highest exponent. I'm going to use that to answer both of those questions. The leading coefficient is the coefficient of that term. The degree is the exponent of that term. The highest exponent in this polynomial is 7. Lastly, the constant is this number that doesn't have an x with it. Plus 3, my constant, is positive 3. We're going to spend a couple days working on learning all of these terms, so you're going to get some practice today and then more again tomorrow.